Vectors. Let U be represented by the directed line segment from P to Q. That's important. Every vector has an initial point and an ending point. So this one is U. Let's see what that looks like. Here is 0, 0, that's P. Here is 3, 2, that's Q. Let V be represented by the directed line segment from R, 1, 2 to S, 4, 4, which is right there, R to 4, 4. Okay, as shown in the figure. Show that U equals V. So we're trying to show that these two vectors equal each other. Now there's two parts to vectors. You guys remember those two parts? Magnitude and direction. Okay, now magnitude, whoops, I spelled it wrong. Magnitude is length. So you guys have to find the length of the line. I guess I shouldn't call it a line. Maybe I should call it a ray and be more mathematically correct. But it doesn't matter. It's just the length, like the distance that the ray is. So I'm not gonna remind you guys of the distance formula. Instead, I'm just gonna draw this, and I want you guys to find the length of R to S. I'm gonna give you guys a minute. Ready, go. So what you should have noticed right away is that this is 2 and this is 3, and we're dealing with the right triangle. And if you guys are dealing with the right triangle, what are you gonna do? Pythagorean theorem. Pythagoras? Yeah, so we're going to take 2 squared, and then we're going to get 3 squared. You got to add those together. That's going to give us V squared. I probably shouldn't use V, but I'm using it right now. Maybe I should use C. And then I get 4 right here. I get 9 right here. And then I get 13 equals V squared, which then I get V equals the square root of 13. So what is the length of RS? Rad 13. Actually, I should say, what is the magnitude of RS? Another way to write magnitude, check this out. You guys can go V, and you do this double line thing. V equals the square root of 13. So if we want to see if these are equal, these two vectors, their lengths have to be the same. They have to be. Their magnitudes have to be the same. Now I'm going to throw up for you guys the distance formula, and then I want you guys to we're going to kind of take a pause on the vectors for a second. I want you guys to figure out why or what the different parts of the distance formula represents, because you guys just used the Pythagorean theorem to find it. Here's the distance formula. You get x's, you subtract them, you square it. You get y values, you subtract them, you square it. And then sometimes there's a 2, like it's x sub 2 and x sub 1. And then y sub 2 and y sub 1. But, you know, the 2 and those 1s aren't actually necessarily needed. But anyways, talk to your teammates and see where they all come from. So those x's right there, you would take the 1 and the 4, you subtract them, because, you know, you got 1 and 4. You know, the 1 right there, the x, and the 4 right there, the x. You subtract those, and then you square it. You take the y's and subtract those, and you square it. And guess what you get? You get 9 and 4. Hey, that's because 1 minus 4 is negative 3, which is the same thing we got right here. You guys remember this 3 that we got right here? But how did we get this 3 if you drew this triangle? You probably just counted, right? You probably didn't subtract the x values. And if you did, that's awesome. That's exactly what the distance formula does. And then we do the same thing with the y values. And that's this 2. That's the rise. And then we get a square root. And then so we get the square root of 13. So we can see that the magnitude checks out. The magnitude works. The magnitude is equal. Now the other thing that we have to make sure of for vectors to see if they're equivalent is the direction. Are they pointed in the same direction? How do we know for sure if they're pointed in exactly the same direction? A lot of you guys said slope, which is correct, but slope is not the only one. Okay, yeah, I got the magnitudes already. Okay, what is the slope? I'm just going to use m for now because that's a common variable for slope. What is the slope of vector v? We would take the y's and subtract them, and put that over the x's and subtract them. So what would that be? It'd be 4 minus 2, or 4 minus 2, and 4 minus 3. What would the slope be for v? 2 over 3. What would the slope be for U? Is that one? Oh, that one's even easier because the initial point is right here on the origin. And so when you subtract, you get 2 over 3. So our slopes are the same, but that's not the only thing that we have to know about the direction. Because I could have a vector. Let's say it starts right here. And let's pretend it's the same exact length and the same exact slope as that one. Oh, so what else do I have to know? Yeah, we have to make sure we know it's positive or negative. And I don't know, I guess you could say which quadrant you're pointing towards. Or you could say which direction, like upper left or lower left. But I think knowing positive or negative also solves it. So, wait. Isn't this still a positive slope?
Yes. No. Yes.
Like the line itself is. I mean, I know the arrow's going down, but it's a positive slope, isn't it? So you have to know which direction we're pointing at. So what direction are these two pointing at? And are they pointing the same direction? I'm going to say, northeast. So I'm going to say quadrant 1. They're both pointing towards quadrant 1. So you got to know the direction and the slope. The slope's important because it tells you how steep it's pointing.